Welcome. Today we're diving into the fascinating world of the Sagaing Fault, one of the most geologically active regions on Earth. Recently, a powerful 7.7 magnitude earthquake struck Myanmar, drawing global attention to this seismic hotspot. But what exactly is the Sagaing Fault and why is it so significant? In this video, we'll explore its geological features, tectonic setting, and the reasons behind its frequent earthquakes. By the end, you'll have a clear understanding of why this fault line is so crucial to the region's landscape and seismic activity. March 28, 2025, Myanmar experienced a massive 7.7 magnitude earthquake. This event was triggered by strike-slip faulting along the Sagaing Fault, a major geological boundary that separates the Indian plate from the Eurasian plate. The earthquake's impact was felt across Myanmar, Thailand, and even parts of India, causing ground ruptures and widespread concern. Such seismic events highlight the importance of understanding the Sagaing Fault's behavior and its role in shaping the region's geography. Sagaing Fault is not just any fault line. It's one of the longest and most active strike-slip faults in the world. Stretching over 1,200 kilometers, it accommodates more than half of the right lateral motion between Sundaland and India. This means it plays a critical role in the movement of tectonic plates in Southeast Asia. The fault acts as a boundary between the Indian and Sunda plates, linking major thrust systems in the north with the Andaman Sea in the south. Its activity is a key reason for Myanmar's frequent and sometimes devastating earthquakes. Strike-slip faults like the Sagaing Fault are vertical or nearly vertical fractures where the blocks of earth move mostly horizontally. The movement is caused by shearing forces, and the direction of movement determines whether the fault is left lateral or right lateral. The Sagaing Fault is a right lateral fault, meaning the opposite side moves to the right. Other famous examples include the San Andreas Fault in California and the Anatolian Fault in Turkey. These faults are known for producing powerful earthquakes due to the immense energy stored and released along their lengths. Myanmar is uniquely positioned at the intersection of several major tectonic plates, the Eurasian, Indian, Sunda, and the Burma microplate. This complex tectonic setting makes the region one of the most geologically active areas in the world. The Indian plate moves northward, colliding with the Eurasian plate and subducting beneath the Burma plate. The Sagaing Fault acts as a partition between the Burma plate and the Sunda plate, facilitating horizontal movement and frequent seismic activity. Sagaing Fault is more than just a boundary. It's a dynamic system that links major thrust zones in the north, such as the Naga and Lohit thrusts, with the Andaman Sea in the south. Its movement accommodates about 50–55% of the overall plate motion in the region with a slip rate of 1525 per year. Over millions of years, this has resulted in an accumulated slippage of up to 700 kilometers. Such movement is responsible for the frequent earthquakes and the unique landscape of Myanmar. Earthquakes along the Sagaing Fault are caused by the buildup and sudden release of seismic energy. As the Indian and Sunda plates move horizontally against each other, stress accumulates along the fault until it's released in the form of an earthquake. The alluvial deposits in the Chinwon River Valley can amplify seismic waves, increasing the impact of these events. This explains why central Myanmar often experiences moderate to strong earthquakes, some exceeding magnitude 7. Sagaing Fault stretches over 1,200 kilometers in length and is about 100 kilometers wide. Its sheer size means that when it ruptures, the effects can be felt over vast distances. The recent 2025 earthquake caused a rupture that extended from the Mainchak source all the way to Bangkok in Thailand, as well as Mandalay and Naypyidaw in Myanmar. Such widespread ground movement underscores the fault's significance in regional seismicity. Central Myanmar has a long history of strong earthquakes. Between 1930 and 1956, 6 major quakes of magnitude 7 or higher struck along the Sagaing Fault or nearby structures. These events have shaped the region's landscape and influenced local communities. Analysis of past data shows that more than half of the Sagaing Fault has ruptured in the last few decades, indicating ongoing seismic risk. Indian and Sunda landmasses move horizontally against each other along the Sagaing Fault. This horizontal movement is a key driver of seismic activity in the region. As the plates grind past each other, energy is stored and eventually released as earthquakes. The Sagaing Fault's role as a transform boundary makes it a focal point for these powerful geological processes. While the Sagaing Fault is unique to Myanmar, it shares similarities with other major strike-slip faults around the world. The San Andreas Fault in California and the Anatolian Fault in Turkey are both right lateral strike-slip faults, just like the Sagaing. These faults are known for their potential to generate large, destructive earthquakes, making them important subjects of geological study and disaster preparedness. Over time, seismic energy accumulates along the Sagaing Fault due to the constant movement of tectonic plates. When this energy is finally released, it can cause significant ground ruptures and widespread damage. The 2025 earthquake is a recent example, but similar events have occurred throughout history. Understanding how and why this energy builds up is essential for predicting future earthquakes and mitigating their impact. Sagaing Fault has shaped the landscape of Myanmar in profound ways. Its movement has created ridges, valleys, and other landforms that define the region's geography. The fault also acts as a boundary between different geological zones, influencing soil composition, river courses, and even patterns of human settlement. These geomorphological features are a testament to the fault's power and ongoing activity. Scientists continue to study the Sagaing Fault to better understand its behavior and predict future earthquakes. Advanced monitoring systems track ground movement, seismic activity, and changes in the fault structure. This research is vital for improving earthquake preparedness and reducing the risk to communities living near the fault. As technology advances, our ability to anticipate and respond to seismic events will only improve. Summary: the Sagaing Fault is a major geological feature that shapes the landscape and seismic activity of Myanmar and surrounding regions. Its complex tectonic setting, frequent earthquakes, and ongoing movement make it a subject of intense scientific interest. By understanding the fault's behavior, we can better prepare for future earthquakes and protect the communities that call this region home. Thank you for joining us on this journey through the Sagaing Fault's seismic secret.